Hello students, hope you are fine. So we will discuss today about the three basic and challenging problems on circles and the tangents unit. And this question I have already shared in my previous video. So please have a look on the basic concepts which you require for solving these type of questions. So let's proceed. So our first question is, this is a circle and AB is the diameter of the circle, and it's given that O is the center, so AO is equal to OB is the radius, and also there is a chord which is CD which is equal to the length of the radius. So it's given that AO is equal to OB is equal to CD, okay, and you are joining AC and DB and you're extending these two lines which meet at each other at point E. And you have to find out the angle AEB. So that's your objective. So let's proceed. So how can we approach this problem? We can approach this problem by doing some construction. So first of all, let's join this DO and CO. Okay, I'll tell you the reason why. We are also doing a second construction here, and that one is BC. So we are joining BC. Okay, so let's write it down now. So we have done a construction of joining BC, OC and OD. Okay, so we have joined these three line segments. Now if you have a closer look into this circle, you will see that this already is given that CD is equal to OB. That means it's the radius, and OD is also the radius because D is a point on the circumference and O is the center. Similarly, OC is also the radius. So if you have a closer look on the triangle OBC, you will see that it is forming an equilateral triangle. Okay, so let's write it down now. So let's write it down in triangle ODC. So we are talking about a triangle ODC. Now since it's all the sides are equal, so OD equal to OC is equal to BC is equal to radius, right? So we can say that since all the three sides of this triangle are equal, it's forming an equilateral triangle. So we can say that therefore triangle ODC is an equilateral triangle. And what's the angle of an equilateral triangle? Yes, you are right, it's 60 degrees. So we can write therefore angle, I'm talking about this triangle, so this angle I know that angle COD is equal to 60 degrees because it is a part of the equilateral triangle, right? Now coming to the second construction, we have also joined this BC, right? We have joined BC. Now if you have a closer look into these two parts, I will change the color so that you can understand it better. Now have a look into these two parts. This angle which is 60 degrees. So this is on this particular arc. Okay, so it is forming on the minor arc CD. Now we know that one of the theorem is there, the central angle. So it is forming a central angle. Angle COD is a central angle. So it is forming a central angle, and we know that a theorem is there where the central angle is double the inscribed angle. An inscribed angle is any point, whatever we take, any point on the remaining part of the circumference, that angle will be half of the central angle. So from this theorem we can say that this angle is 30 degrees if this is a 60 degrees. So if this is 60 degrees because this point B lies on the remaining part of the circumference. Okay, so it is forming an inscribed angle. So, and we can say here that angle CBD is equal to 30 degree. Since, so what we will write here? Since angle CBD is the inscribed angle of which angle? Of the circle, and so we can write inscribed angle and is half of the central angle. And what is the central angle? It is COD, central angle, angle COD, which is equal to 60 degree, right? So we can conclude. So we have found this angle as 30 degree. Okay, let's keep it into our mind. This is part 1. So let's keep it into our mind, which we'll use in the future. Now, second thing, if you look here, this is a triangle. This ACE is a line segment, right? It is a line segment and AB is the diameter, right? So AB is the diameter and hence arc ACB is a semicircle. So it is a semicircle and any angle on this semicircle will be 90 degree. We know that. So we can say that angle ACB. So this angle, I am talking about this angle. Angle ACB will be equal to 90 degree. What reason you will write? You will write angle in a semicircle, right? So angle in a semicircle becomes 90 degree. So this is 90, if this is 90 degree and ACE is a line segment, so we know that the angle on a line segment, linear pair axiom, we know that angle ECB is also 90 degree because the whole angle will be 180 degree. So we can write, therefore, angle ECB, the remaining ECB is equal to also 90 degree through linear pair axiom. So we can write linear pair axiom. Okay. So now let's revise what we have done. This angle is 90 degree. This angle is 30 degree. Now think about triangle E, C and B. So think about triangle ECB. We know one angle is 90 degree. We know another angle is 30 degree. So what will be the remaining angle? Yes, we can use the angle sum property, which is 180 degree, and we can find it out the remaining angle. So let's see here how we can say, therefore, in triangle CEB, angle E plus angle ECB plus angle CBE is equal to 180 degree, which means angle E plus, we know that this is 90 degree and we know that this is 30 degree is equal to 180 degree. Correct? And hence, what can you write? You can now derive it very easily. We can write angle E is equal to 180 minus 120, which is equal to 60 degree. So this is your answer. This is how you will approach the problem. So students, this is our second question, and in this question it's given that these are the two circles, okay, and you can see that AB and CD are the two tangents on these two circles, and these two tangents intersect at point E. Okay, so this is given, and you can see from the figure that the radius of these two circles are respectively OA, OC for this one, and O prime D and O prime B respectively for the second circle. So our objective is we need to find that, prove that O, E and O prime are collinear. Okay, collinear means what? They lie in a straight line. So that's our objective. And this is also an important question, students. You can expect this as a 3 marks question or a 4 marks question even. Okay, so let's proceed how we can approach this problem. So we can write here that in triangle, if you see that AB and CD, so this AB and CD are the line segments, right? And so they are forming angles. These two angles will be equal. Why? Because they are vertically opposite angles. So if you see here, these angle and these angle will be equal. So we can write here, from the figure we can write angle AEC will be equal to angle DEB. Why? Because we can write here vertically opposite angle, right? So this is the reason. Now second thing very important, you can see we are comparing. So let's name it as number 1. So this is our first. Now second thing, you can write comparing. Let's compare the two triangles, triangle AOE and triangle COE. Have a look closely into this particular triangle. So we can write comparing triangle AOE and triangle COE. You can see that they are congruent. Why? Because I am not explaining this. You can write it down in your notebook. This angle is 90 degree because the tangent always makes 90 degree with the radius. So this angle is 90 degree. This is the radius. So one side will be equal. AO is equal to OC and OE is the common side between these two triangles, right? So we can say that these two triangles are congruent. By which theorem? Yes, you are right. It is RHS because one of the angle is right angle, one side and one hypotenuse. So we can write triangle AOE will be congruent to triangle COE through RHS. Correct? Now since they are congruent, that means all the corresponding part of congruent triangles will be equal. Now if you check here, you can check here these two angles. This angle and this angle are the parts of the congruent triangle. Hence we can say, let's name them as angle 1 and angle 2. Let's name it as angle 3 and angle 4 for our writing purpose. So we can say that angle 1 equal to angle 2, right? Why? We can write here as CPCT. Correct? So this is done. Now angle 1 is equal to angle 2. Similarly, we can write angle 3 is equal to angle 4 because we can also prove these two triangles are congruent and these are also the corresponding part of congruent triangle. So we can write similarly angle 3 will be equal to angle 4. Understood? So now what we can write, this is equation 2 for example and this is equation 3 for example. What can you say? That since angle 1 is equal to angle 2 and angle 3 is equal to angle 4, so we can write angle 1 plus angle 2 will be equal to angle 3 plus angle 4. Because they are vertically opposite angles, these two are already equal. So we can write angle 1 plus angle 2 is equal to angle 3 plus angle 4. Hence we can write, now angle 1 is equal to angle 2. These two are equal, we have already proved. So we can write twice of angle 1 will be equal to twice of angle 3. Right? So this angle will be equal. So if twice is equal, then we can say that angle 1 is equal to angle 3. Isn't it? We can cancel 2 from both sides. Isn't it? So we can write angle 1 is equal to angle 3. Now, see here. We have found that this angle is equal to this angle. Okay. Now, how can you prove? Now, this angle E. This angle, if you check this angle versus this angle. This is also vertically opposite angles. This is also vertically opposite angles. So we can write these two angles will also be equal. isn't it? They are also vertically opposite angle. So we can write here, from the figure or from the diagram, we can write angle 1 plus angle 2 plus angle CEB plus angle 4 plus angle 3. I'm just making all the angles, whatever you can see, whatever you can find out there, plus angle DEA will be equal to 360 degree, isn't it? It is 360 degree. Now we know that angle 1 and angle 3 are equal. Similarly, we know that angle 2 and angle 4 are equal. And this angle are vertically opposite angle. So we can write, therefore, twice of angle 1 plus angle 2 plus angle CEB will be equal to 360 degree. Just we are minimizing the numbers because we know that angle 1 is equal to angle 3 and so on. So here we can write, just cross multiply angle 1 plus angle 2 plus angle CEB will be equal to 360 by 2, that is 180 degree. And if this is 180 degree, what can you conclude? That means this is a straight line, isn't it? So we can write, therefore, O, E and O prime are in a straight line. Okay, so this is how we have approached the problem. Disintegrate the problem and try to look into the figure very closely. You will be able to find it out. We have used very basic concepts and you will get 3 to 4 marks by solving it. Okay. Students, this is also a very important question and it has come to your examinations for 4 marks. You can expect it around 4 marks, this question. So in this question, it's given, the figure is given and this is a circle with center O. You can see that this is center O and B is an external point. Similarly, A is an external point, D is an external point and C is also an external point from where the tangents are drawn towards the circle. Okay, and it's given that angle ADC is 90 degree. ADC means this angle, ADC. So this angle is given as 90 degree. So now this is given and similarly various measurements are given, like BP is given as 25 centimeter and BC is given as 38 centimeter and similarly CD is given as 28 centimeter and we have to find out the radius of the circle. So this is our objective. So let's proceed. So we will use a specific theorem in tangents that you can imagine from this equation. Since there is an external point, imagine or think which equation or which theorem we can use. Yes, you are right. There is tangents from an external point, right? So we can use that theorem. Now here we can write the solution and here since B is an external point, we can say that BP will be equal to BQ. BP is equal to BQ, isn't it? Because B is an external point and they are forming tangents. Tangents from an external point are equal. So we can write here tangents from an external point are equal. So just write down the theorem. Done. Now if BP value is given as 25, then BQ will also be 25, right? And it is given the value of BC. The BC, the whole BC is given. So you can write BC is equal to 38 centimeter, which is equal to BQ plus CQ. We are just dividing. And BQ is equal to BP. So you can write here as 25 plus CQ. So what is CQ now? So we can write CQ in other words, and rewriting CQ is equal to 38 minus 25, which is equal to 13. Right? 13 centimeter. So this part we have found. CQ we have found. That is 13 centimeter. Okay. Now, if CQ is 13, then you can name this point as, for example, M. CM will also be 13. Why? Because C is an external point. So we can write CQ will be equal to CM. Same theorem. Tangents from equal. Please write it down. Tangents from an external point are equal. Right? So CQ is equal to CM. So CM, therefore CM will also be 13 centimeter. Isn't it? So CM is also 13 centimeter we have found. Right? Now it is given that CD is 28. So CD is 28, that means MD is what? It is just 28 minus 13. So we can write, therefore MD is equal to CD minus CM, which is equal to 28 minus 13, 15 centimeter. So MD is 15 centimeter. Okay, now D is also an external point, right? So if this is 15, this is also 15, isn't it? Sorry. So this is also 15. Now, secondly, have a look carefully. This is given as 90 degree. It is given as 90 degree, and we know that the radius makes an angle of 90 degree with the tangents, isn't it? So radius makes an angle of 90 degree with the tangents, and hence this angle has to be 90 degree. So all the angles are 90 degree, isn't it? And the adjacent sides are equal. That means we can say that what type of quadrilateral it is? It is a square. So OMDS is a square. Okay. So here just write it down that since angle MDS is equal to 90 degree, right? And angle OMD will be equal to angle OSD is equal to 90 degree. Reason what? Tangents and radius make an angle 90 degree at the point of contact. So write it down just at point of contact, POC. Okay. So point of contact, in point of contact the angle is 90 degree. Adjacent sides, so since therefore quadrilateral MOSD is a square. You can add that adjacent sides are also equal. So we can write MO is equal to OS is equal to radius, which are the adjacent sides. Okay, so write it down just to conclude. So I am writing it here now. So you can conclude here, therefore MD is equal to DS is equal to MO is equal to OS is equal to what? We have already found that the radius is, MD is 15 centimeter. MD is 15 centimeter we have found. So we can write it is 50 centimeter. So radius is equal to 50 centimeter. This way you will do. Okay. So this type of question you may expect in an examination. These are also some possibilities of questions that I am explaining here. If If you have any doubt, you can write in the comment section. Thank you for watching.